Number 3, graph the lines on the axis to the right. When you graph, most people, as they start off in math analysis, they want to just say, let's put it into y equals mx plus b. So we'll take negative 2x minus 6y equals 18. Add 2x to both sides, we get negative 6y equals 2x plus 18. You have to be very careful to make sure you're carrying down that negative. We're going to divide by negative 6. You do not have to show this. I'm going to show it for this example. But a lot of people make mistakes on this. The kind of mistakes they'll make is they'll leave off the negative, or they won't do this division correct, or they won't divide all of it out. We'll get y equals 2 divided by negative 6 is negative 1/3 times x, which is the same as negative x over 3. And then 18 over negative 6 would be negative 3. Now, when we're looking at our y equals mx plus b, our b is our y-intercept. That point is 0, negative 3. Our slope is negative 1/3. Make sure we label our scale again, at least every 5. 2, 5. The reason why we're going to label it every 5 is you can quickly determine what any point is. You must have your scale, because the purpose of giving a graph is to show information quickly. We shouldn't have to try to count and see what exactly is that. We have 0, negative 3, so we're starting at the origin, go down to negative 3. And now we have a slope of negative 1 over 3, which is down 1, right 3. How can I get another point but not going down? We could do it as up 1, a positive 1, divided by a negative 3. So we're going to go up 1 and to the left 3. Take out your ruler and connect the dots. Now let's graph the next one. So I did y equals mx plus b here. There's another, one thing I didn't address is you should graph 3 points. If the points are close together, then you need at least 3. If they're far apart, then you can get by with 2. But typically having 3 would be better, especially if you're using y equals mx plus b. I'm going to give you another method. We have x minus 3y equals 6. Sometimes, instead of putting into slope and y-intercept, and this one's not particularly hard, we can find the x and y-intercepts. Remember, for the x-intercept, and we'll review this again later on, if it's on the x-axis, every single point on the x-axis has the same y value. It's a y equals 0. So we would say y equals 0, and we get x equals 6. So we have a point 6, 0. Now graph the y-intercept, and on the y-intercept, every single value has x equals 0, and that's what we assumed when I wrote this down at 0, negative 3. So when we have x equals 0, we'll get negative 3, y equals 6, y equals negative 2. So we'll get the point 0, negative 2. Let's see, 0, negative 2, and then 6, 0. Given the size of what we're working on here, that's probably okay. We could use this idea, since we have 2 points and it's a line, it has a constant slope. So we could have another point. This is going over 6 and down 2. We could go over 6 and down 2 again, and we have a third point. The more points we have there, the more accurate we'll be. Now, we've graphed the 2 lines. Estimate the solution. We need to figure out what is this point. A lot of people want to say in their estimate, we know it's not an exact value. They want to say things like a half or a quarter or a third. The quarter and a third are just too precise. We cannot measure this accurately. About the best we can do is 1 decimal place. we know it's negative. We're going to be negative between -1, -2. We could guess somewhere around -1.5, -1.6. Either estimate right now would be perfect. And then we have -2, somewhere between -2 and -3. Actually, I'd probably even say -1.6 on there. And then this would be -2.5. So that is our estimate for the solution, -1.6, comma, -2.5. That doesn't mean what you just graphed is going to have those exact values. Maybe yours says -1.5, maybe it says -1.7 or -1.4. What you want to do is look at it and try to estimate. This is pretty close to the middle vertically, and it seems that maybe a slightly to the left of the middle on the horizontal. Now, how can we solve the system of equations more accurately? How do you check to show that the point is on both graphs? Well, how do we solve the system? We solved it here graphically, but one of the problems with it is not very accurate. How can we solve this algebraically? Do you remember the methods that you did last year? One method is substitution, and the other method is the add-subtract method or linear combination method. However you want to call it is fine. Either method will work. When we have x and y on the same side of each equation, typically the linear combination or the add-subtract method's better. So let's do that. -2x minus 6y equals 18. We'll rewrite them. Minus 3y equals 6. The linear combination, or the elimination method also it's called, what we want to try to do is eliminate one of the variables. So we have to look at this and say which one of the two equations is easier to get rid of. They're not a huge difference, but I would vote for the x, because if we multiply by a +2, then we have them the exact opposite. They're going to be the same, except opposite in sign. Whereas if we multiply it by, when we get rid of the y's, we'd want to multiply by -2. Typically, it's better for people to add the equations and subtract. More mistakes are made when students subtract. So put an arrow going across. We're going to put a 2. That's saying we're multiplying by 2. We can put a little dot there. If we don't put anything on it, just carry it over. So -2x minus 6y equals 18. And then 2x minus 6y equals 12. Let's add them up. This will give us a 0. You don't have to write 0. I'm just putting it there just to emphasize it right now. We get -12y equals 30. Divide by -12. Again, this is up to you whether you want to write that or not. Just be careful on your simplifying of this fraction. What goes into 30 and 12? The biggest number would be 6. So we have 5 and 2. Now how do we get our x value? We have two equations and we have a y value. We need to plug the y value into the equation. Which equation? It's your choice. Both will work. We want to pick the one that's easier, and that looks like it would be the second one. So we'll have x minus 3 times -5 halves equals 6. So we'll have x plus 15 halves equals 6. Now, how do you want to deal with this? It's up to you. I would just move the 6, change it into 12 halves. So we have 12 halves minus 15 halves, and we'll get x equals -3.5. So our answer is not just stopping there, it's the point -3 halves comma -5 halves. So it looks like my graph up here was slightly off in my estimate of -1.6, but that's okay for a graphing. Now, how do we check to show that this point is on both graphs? You plug it in. You know it works on the second one because that's how we got the x value. So really what we need to do is just check the equation we did not use. We used the second equation in order to find the x, so we want to plug it into the first equation to check. we'll have negative 2 times negative 3 halves minus 6 times negative 5 halves. Does this equal 18? We'll have a negative times a negative will be positive. The 2's will reduce. If it helps you, you can put a 2 over 1 there, and this will give us 6. And then the 2 here reduces with the negative 6, and we'll have negative 3. Negative 3 times... Oh, I put 6 down. I forgot I did not reduce that. This would be 3, and then 15 equals 18. So we have 18 equals 18, and yes, it checks out. And that's all for this video.